All right, let's talk about the secret sauce that makes computer programs feel, well, smart. We're going to dive into decision making. This is how code stops being just a list of instructions and starts to think, react, and choose its own adventure based on what's happening.
I mean, really think about it for a second. How does your calculator know you want to add instead of subtract? It's all thanks to this powerful idea called decision making. It's the core logic that turns a program from a simple script into a dynamic, responsive tool. So here's our plan. We'll start with the why our code even needs to make decisions in the first place. Then we're going to open up the main toolkit, the whole if-else family and the switch statement. We'll even check out a few oddballs before we wrap up with the most important part, knowing exactly which tool to use for which job.
Okay, so let's get right to it. Why is this whole topic so fundamental? Well, imagine a program that did the exact same thing every single time you ran it, no matter what you did. It'd be predictable, sure, but it would also be pretty useless, right? Decisions are what make software interactive. They make it powerful. At its heart, decision-making is all about asking questions. Our code looks at a condition, like, say, is the user's age greater than 18? And based on whether the answer is true or false, it chooses which bit of code to run next. That simple fork in the road is what gives software its intelligence. And this right here, this is our entire decision-making toolbox in C. You can see we've got a few key players: the super versatile if-else statements, the really compact ternary operator, and the super efficient switch statement. Let's open this thing up and see how each one works. First up, let's grab the most common tool in the box, the good old if-else statement. You can think of this as the hammer and screwdriver of programming logic. It's the workhorse you're going to be using for most of your decision-making tasks. So the simple if is the most basic fork in the road. The program asks one simple yes or no question. If the answer is yes or true, it runs a specific chunk of code. If the answer is no, it just skips right over it and moves on. Easy as that. Let's break this down. On the left, you've got the basic structure, the syntax. You see the word if, and then the condition you're testing right inside the parentheses. Now look at the real-world example on the right. The code asks, hey, is the age variable greater than or equal to 18? Well, since age is 20, the answer is true. So it goes ahead and runs the code inside the brackets, printing eligible to vote. But what if you want to do something specific when the condition is false? That's where else comes in to save the day. The if-else statement gives you two clear paths, one for true and a default path for false. This guarantees that one of those two blocks of code is always going to run. Here's a classic example, checking if a number is even or odd. The condition is asking, if we divide this number by 2, is the remainder 0? For the number 5, the answer is no, which means the condition is false, so the program completely skips the if block and jumps straight to the else block, printing odd. The key takeaway here is that with if-else, your code always has a path to follow. Now, you can start to get more complex by putting if-else statements inside of other if-else statements. This is called nesting. It's really powerful, but it comes with a huge warning sign. It can make your code incredibly hard to read and understand. Just take a look at this code for assigning school grades. See how the else block has another if-else inside it, which then has another one inside that. This deep indentation creates this pyramid of brackets that's just a nightmare to follow. If you have a lot of conditions, this becomes a huge headache to debug. Thankfully, there is a much better way to handle this kind of situation. It's called the else-if ladder. Instead of nesting and creating that messy pyramid, it creates a clean, straight line of checks. It tests the first condition. If that's false, it just moves on to the next else-if, and so on, right down the ladder. Now, this is a world of difference, right? Compare that messy grade pyramid to this code for finding the day of the week. The logic is so clean. It just flows straight down. If day isn't 1, it checks if it's 2. If not, it checks 3. You get the idea. It's sequential, it's easy to read, and believe me, it's way easier to fix if something goes wrong. All right, let's switch gears a bit. What if you're not checking a bunch of different conditions, but instead you're checking one single variable against a list of specific known values? For that exact job, we have the perfect tool, the switch statement. The switch statement basically works like a dispatch center. You give it one variable, and it instantly finds the case that perfectly matches that variable's value. Instead of checking conditions one by one like a ladder, it jumps directly to the correct block of code. That makes it more efficient and a lot cleaner than a really long else-if chain. So in this simple calculator, the code switches on the operator variable. Since the operator is a star, it jumps straight to case star, performs the multiplication, and then hits the most important word on this slide, break. Break tells the program, okay, we're done here, get out of the switch. If we forgot that break, the code would just fall through and accidentally run the division case right after it, giving us a totally wrong answer. That's why break is absolutely essential. Now let's quickly cover a couple of specialized tools. One of them is a fantastic little piece of shorthand, and the other is a really powerful but kind of dangerous statement that you have to use with extreme caution. This is the ternary operator. It's basically a super compact way to write a simple if-else statement all on one line. The structure is simple. Condition, question mark, value if true, semicolon, value if false. In our example, it checks if x is greater than y. It's not, so it returns the value after the colon, which is y, or 20. It's perfect for quick and simple assignments like this. And now for the big outlier, the go-to statement. This lets you make an unconditional jump to any other point in your code that you've marked with a label. And as our source material warns us, this is almost always a bad idea. It can make the flow of your program incredibly confusing, creating what programmers call spaghetti code. It exists, but honestly, you should probably just pretend it doesn't. Okay, so we've looked at the entire toolkit. We've seen all the different tools. The final and maybe the most important piece of the puzzle is knowing which tool to pull out of the box for which job. This table right here is your ultimate cheat sheet. Let's run through it real quick. Got one single condition to check? Use a simple if. Need to clear this or that choice? If else is your friend. Chaining together a bunch of related checks, like that grade system, the else if ladder is the way to go. Checking one variable against a list of specific options, like a menu, switch is your most efficient bet. For those quick one-line assignments, the ternary operator is fantastic. And go-to? Yeah, just leave that one in the toolbox unless it's a real emergency. So that's our deep dive into making decisions in C. You now have the fundamental building blocks to create programs that aren't just following a script, but are actually intelligent and responsive. The only question left is, what will you build with them?